All right, so you might remember in passing, I said that given some statement like this in logic, it's undecidable. There's no algorithm which will tell you whether or not the sentence is true, right? It's a hard, knowing whether a sentence is true is computationally a very hard problem. And I'm just going to give you intuition to why that's the case, right? The blue guy has to come up with the why, right? And for which some function is true, right? He must find and name some solution to this problem, right? And it may be a very, very hard computation problem to find this why, right? So, so what are some hard uncomputable problems? Well, will my Turing machine, will my algorithm ever halt? That's an undecidable problem, right? Find a sequence of yes, no instance, right? You have some circuit of andors and nots, and you want to find for an assignment to the variables true, false, for which the circuit is satisfied. Now that one's not uncomputable, but it's uncomputable in polynomial time, right? They're 2 to the n such inputs to search among, right? Or now suppose that this is some polynomial on n variables that are real values, right? Or even not real values, just integer values, right? Is there a sequence of integer inputs that satisfy them, right? Well, there's an infinite number of integers to search for, right? So how can this guy find a y that satisfies this? It becomes an a hard problem. So similarly, if we're taking the negation of it, and we want to say for all, you want to prove for all x, it doesn't satisfy it, right? Well, this task is hard too, right? That now the sort of the guy, the adversary has to come up with a counterexample or prove that there's no counterexample, and so it's a hard thing to do, right? So I just stuck these in here too, so that you can appreciate why coming up with the proof can be hard. And then even here, the blue guy, after the red guy comes up with an x, right? He has to prove, right? He's saying, well, let x be an arbitrary value. Now he has to prove that x is not a solution to this problem. And he has to prove it's not a solution to the problem, just knowing it's an arbitrary value. So it's not a solution problem because there are no solutions to it, right? If it's true that for every x, it's not a solution, then when x is an arbitrary solution, he has to prove that it doesn't have any solutions. And that's hard to do. All right.